This is the explanation for the week 6 problem set. Going on to question 1, if we are asked to evaluate the integral of 1 over x squared minus 4x minus 5x dx, I found that you can factor that with using x minus 5 and x plus 1, putting that over our a plus b. So 1 over x minus 5 times x plus 1 equals a over x minus 5 plus b x plus 1. Now solving for x equals -1, we get -6b equals 1, or b equals 1/6. Solving for x equals 5, we get 6a equals 1, or a equals 1/6. Plugging that into our equation, we end up getting our 1 over 6 x minus 5 minus 1 over 6 x plus 1. Integrating that, we find that our answer will be ln of x minus 5 divided by 6 minus ln of x plus 1 divided by 6 plus c. Moving on to question 2. We are asked to evaluate the derivative of 1 over x times x squared plus 1 dx. Step 1 here is to find that is a factored from x cubed plus x, so this cannot be factored anymore. Using one of our equations found, which is our 1 over x squared plus 1 equals a over x plus bx plus c divided by x squared plus 1. And through here, we multiply the denominator of our 1 over x times x squared plus 1, getting our a and our b and our c values, and then we solve for x squared values for x and for x is 0. Solving this, we determine that 0 equals a plus b, 0 equals c, 1 equals a, so a is 1, b is -1, c is 0. Plugging in these values for our a, b, and c, and integrating, we then find that, well, our first one is just 1 over x, so that's just ln of x. And our second one I found by substituting u in for x squared plus 1 and du in for 2x dx, and then finding that our x, which will be on our top, will just be 1/2 of du. So that integral will be integral 1/2 du over u, which equals 1/2 ln of u. Then plugging back in our numbers, which is just -1/2 ln x squared plus 1. And our final answer would be ln of x minus 1/2 ln of x squared plus 1 plus c. And moving on to our last question here, we are asked to evaluate the integral of dx divided by x minus 2x plus 5 squared, which is just 1 over x minus 2x plus 5 squared dx. And this is a repeating factor underneath our denominator, so we'll have our a is divided by x minus 2, our b is divided by x plus 5, and our c is divided by x plus 5 squared. Multiplying that out by the denominator of our original value, we get our a, b, and c values, and then solving for our x squared, x's, and our zeros, we find that our a is equal to 1 over 49, our b is equal to -1 over 49, and our c is equal to -1 over 7. Plugging that in for our values, we can then integrate this, which will be the integral of 1 over 49 times x minus 2 minus 1 over 49 times x plus 5 and minus 1 over 7x plus 5 squared dx. Integrating the 1 over 49s is pretty easy. It's simply going to yield us our ln of x minus 2 divided by 49 and our negative ln of x plus 5 plus 40 divided by 49. And for our 1 over x plus 5 squared dx, I use u substitution for u is equal to x plus 5 and du is equal to dx. And through there I found that our value is going to be 1 over 7u, which, plugging that into our original answer, is just 1 over 7x plus 5. And our final answer will be given as ln x minus 2 divided by 49 minus ln of x plus 5 divided by 49 plus 1 divided by 7 times x plus 5 plus c.